And we're going to go to the presentation now. And it should be another interesting program. I know when we were talking about the program on the weekly nets coming up to this presentation tonight, there were people that were saying, you know what, I did that in the past. A long time ago. Jan, you're one of them, right? I've done that in the past, and it was a lot of fun. And you could hear when they were reminiscing about building their first whatever, how enjoyable that was, and they still remember it 30, 40 years later. And then John, K5DVS, who does a lot of building, he's a young college student, but he's been doing this for a long time, said, you know, this is an important part of the hobby is building. You get to really know the physics behind it, the electronics behind it, and you're sort of missing something if you don't at least try to build. And because you'll be able to troubleshoot later on. Jan, you were on last night. He made good points, right? Yeah. He really did make good points. So they're Gregg Harrison and James Bennett, KI5DVS, take the speaker spotlight as they present to us the art of ham radio kit building. Both speakers have built many kits. James has designed many of them as well. He's the owner of Pacific Antennas and QRP.com, right?
QRP Kits, yes.
Yeah, QRPKits.com, and he advertises in the back of ARRL's magazine, QST. And I bought a kit from James, and I didn't ask for any, you know, I just knew he lived near me, and but I just went through his company. I didn't say, hey, whatever. He saw my name, saw my call sign, and he got a hold of me and he said, I've got your kit. I'll be over at your house today. And he didn't ring the doorbell or anything. He just left it on the front porch and talk about service. So anyway, another example of great people in this hobby. And so I'm not going to waste any more time. This is going to be an excellent topic. It did draw a lot of interest on the nets, and so I don't know who's going first or how you're presenting it exactly, but let's welcome Gregg Harrison and James Bennett.
Good evening, everybody. So I was thinking about this a minute ago, that what kind of person's a kit builder. So let me tell you what we are. Or as far as I'm concerned, you'll be a really good kit builder, is if you really get into something and you just go headlong into it and you get it half done, and then you just walk away from it for a while. And so, and then your wife is after you because the entire dining room table is full of kits and soldering irons and all types of stuff. So that's one way of looking at it. But I originally kind of got into this because when I was a kid, I mean, we weren't poor or anything, but if I saw something laying on the side of the road, I'd pick it up and it'd be broken, you know, and I found out many things were broken just because the power cord was worn out or something like that. And I took a few electrical shocks, maybe some of the problems that I'm having nowadays. I got better safety as the years went on, but whether it was a radio, a television, a box fan, I was picking this stuff up and messing with it. And so Dad bought me a soldering iron, and it was made, it was way too hot. But anyway, that's where I first started soldering. And so I wanted to get into the hobby when I was a teenager. I was probably 18 years old. And that project went backwards for me because life came when I turned 18. And I had other things I wanted to do. So later on, I get my license and start moving forward. And I started reading about, well, number one, I noticed how expensive amateur radio equipment was. And so I started reading about the history of amateur radio and how I wanted to I wanted to experience some of the things. It was like, is it your name Steve, sir? I wanted to experience things like he's talking about. I wanted to look back and pay tribute to those guys who built their own stuff, and I thought it was intriguing. So right as I was getting my license, I figured out, hey, I'm gonna build me a 40-meter radio. So I get a hold of this guy. I always just called him QRP Bob. I've still got his phone number in my phone. In Joplin, Missouri. I don't even really remember his call sign. But anyway, it's Wilderness Radio. Real nice guy. He talked to you on the telephone, and he helped me through this build. And then I started figuring out things like, hey, you're going to need a antenna tuner, and you're going to need a meter of some kind, a power meter, an SWR meter. So I just kept building, kept moving forward and building these things. I kind of got out of it again for a while, for 4 or 5 years. Life got busy again. And then I decided I was going to get into CW. So I'm kind of obsessive. So I started doing this. So the first thing that I did is I tried to conduct a touch paddle. So I ended up building this kit over here, and we'll talk about it later. So I started building these touch paddles. And they're not very difficult kits, but we'll kind of get into some of the mistakes that I made, and one of them is when you're buying kits, attempt to find a kit that is maybe amateur radio owned business, much like James, and I'll get into that a little more later. But you find out that you get better product, you get better directions, things such as that. So. This is the radio that got away. This was also a Wilderness radio. It was out of stock when I ordered mine. I said, well, I'm going to order this other one. So what happens is these kits come along, and then they're no more again. It's kind of sad that that happens, but they'll come along and you won't see them again. And so the little radio that I built over here, I saw the other day in kit form, they're selling those now. You can, every once in a while, you can locate one for about $300. This one is unobtainium. I don't know how much it would cost, but I think I paid $80-something for this kit when I bought it. So anyway, so why would anyone want to build a ham radio project, right? Because this is what the kitchen table is going to look like. So I like knowing how things work. I can read directions. That's about the only thing that I do well. So I read the directions. I'll lay out all the parts that I've got, check and make sure all my parts are there, and then I'll read the directions again, and then I'll start an order, one right after the other. And believe me, guys, if I can build it, I promise you everybody in this class can build it. I'm hammers and anvils. That's what I do. I'm not really gentle. So the other thing that I really like about it is I'm really good at letting the smoke out of things. And so you guys know that at the factory, they've got this little needle that presses into all the electronic parts, and it puts a little gray smoke in there and a little sound. And if you mess up and you apply the wrong voltage or amperage, it goes psst, and it has this little smell, and this gray smoke comes out. So I usually end up having to fix a few things along the way. So I really like knowing how they work, and if I break it, which I'm going to end up doing, I can fix it. So it also saves you money, unless you count how much you're worth an hour. Okay, so it's it's going to save you money, but it's really it's about the pleasure of building and having fun with that. So anyway, you get to build it the way you want it. And for those of you who don't know what this is a CW only radio, and there's a guy out there that figured out how to upgrade the firmware in this radio and make it into a single sideband voice 5-watt radio. Just crazy things like this all the time are always coming up. So the rewards in the adventure is in the learning. So that's what I feel the reward in that, just learning and being able to do and then be successful when I'm finished with it. So what equipment are you going to need? And I'm going to defer to James a lot on the back side of this, but we laid some of this equipment out over here on the table. It's really simple. Most of us have it at home. If you need something from James or I, either one, we'll let you borrow our soldering station. You can borrow anything I've got to build with. I don't mind at all. And I know when I give it to you, if you're like me, I'll get it back in like 3 years. So anyway, you're going to need a large work surface area, a workbench, and I put the dining room table in there just so that my wife would be pleased that I owned up to it. So you're going to need a bright work lamp, something can be moved around the bench or the table. And I happened to pick this up. I run around pawn shops and flea markets and things like that. I thought this was a cute little lamp. But one thing I'd like to add about the lamp, there are some good LED lamps out there that have true color, where you can really see the color of like the rings on the resistors and things. But incandescent light I found is one of the best lights, or sunlight. But incandescent light is really, really good. So it's pretty important to have these guys are fancy. They've got the magnifying glasses on their actual lamp. So it's always a good idea to have a good multimeter. I didn't bring a multimeter in tonight, but every part that you get will have values to it. And if you can't identify the part, or you're wondering why is my radio not working, sometimes you have a faulty part. And James, I would never do this. Sometimes I overheat items when I'm soldering, and that can cause damage. So I'll check those values against this. And it's pretty important to have a continuity checker. And James is going to show you one here in just a little while. So a good soldering station and the flux and the tip cleaner. So we've got a couple of examples of soldering stations, but James brought this in, and this is fine. This is fine. You can build anything you want with this. Might make your job a little bit harder, but you can build anything you want with just a little handheld soldering iron. I would definitely recommend something in the 400 degree range, 40 watt. So I think, I'm sorry, sir. I think that the soldering station I have over here goes up to about 850 degrees, which is way too hot for most jobs. But I've got one job over here that took a really hot soldering iron because it was a big slab of metal that I had to solder to. So, but you don't have to start out with this big soldering station. You can start out with a smaller iron, and they're probably half the price or more. So for me, I start making mistakes. That's part of the learning process, right? So you see this wick that this guy's using? I was telling James the other day that I want to say solder, but I actually welded this part into one of my boards. And so I got out the wick. I've always used this soldering wick. You heat up the wick over the top of the solder, put the iron on, everything heats up, and it just sucks the solder into the wick. I had so much solder on there, I mean, I'd really made a mistake that I couldn't get it all off. And it was a three leg, and I couldn't get them off at the same time so I could pull it out. So I got me a solder sucker. Looks very similar to that one. It's called the Vampire. And it works really well. That's the most money I've spent on kit building in 10 years, was getting a solder sucker. And it was like $25. Most of this other stuff I've had laying around since I was a kid. But you can fix your errors and repair that and move right along. Don't get discouraged if you have this happen to you. So I like to just call this the helping hands. It makes it really easy to hold your project boards. You also see there's one over here on the right that it has a place to put your soldering iron, and then you see the sponge that's down there. And that's mainly for cleaning off your tip. And also something I learned is your soldering iron will heat up a little bit hotter if you're not using it. It's nice to kind of have that wet sponge to just dab your tip in, and that'll bring that temperature down just to a little, back to an operating range again. So just a set of pliers. Everybody's got these laying around the house, and I've got a small set over here, but I think, probably at Lowe's, $15 would buy you everything you need for a small electronics kit. The one I use the most, the long needle nose pliers to turn the the edges of the resistors and other parts, and that little end nipper right there to get as close to the board as I can to cut off my parts that are left over. So you will be assimilated, and resistance is futile for all you Star Trek fans. So I saw this and I just had to put it in here. I do not have anything like this, and my wife was laughing at me. So I use a magnifying glass like this one on the end. It is not lit, but it looks like that would be a cool option to have a lit magnifying glass. I just use a simple glass. But I have bought the Harbor Freight little clip-ons right here, and you just flip it down in front of your eye. They work great. They really do. There's 2 lenses, and you can double magnify. So heat sinks. I told you about heating my my parts up too hot. So if I'm soldering on the opposite side of the board, I can apply a heat sink on that other side, and I can get relatively hot when I'm soldering then. And it'll solder to the board really well to the part, and the heat will not affect the part that you're soldering. Be careful. Sometimes you'll grab a hold of the heat sink to move it somewhere else, and it got hotter than you think it did, and you'll have 2 little burn marks on your fingers. So there's 3 different kinds of heat sinks. I generally just use an alligator clip or something of that nature while I'm doing it. It's the cheapest. It's the easiest way to do it. So what equipment do you need? I already talked about this, didn't I? Okay, so this is a recap for everyone who wasn't listening. Move forward here. Okay, so what kind of kit are we going to build? That's one of the first things you're going to think about before you build a kit. Sometimes it's what you need. Sometimes it's just what you think's cool. Something you might want to try out. And a lot of times I've built the cool thing because I wanted to show people. But the CWQRP kit, that's always a great kit. You can get them very complicated, multiple bands, or you can just get a single band radio. James and I are looking at ordering a kit that is a digital modes multi-band transceiver. It's 4 bands, and it's all like FT8 and digital modes. And I think it's $65, something like that. But we're going to order them and put them up on the shelf, and when we got time, we'll build them, or we'll sell them to someone later for $300. So, the key, I showed you, and you guys take a look at that, the capacitive touch key, or you can even get like an electronic keyer to build. And those are pretty simple kits to build. Antenna tuner is always a favorite. And then of course the antenna balun, SWR power meter, dummy loads. So I'm gonna slow down at dummy load, and James will hit this again, I'm sure. That's a really good first kit to build. It's a lot of soldering points, but they're all just in a row. They're all in the same place. You'll probably get 100 contacts soldering when you do a dummy load. So it's a really good first kit. You can build those for your HTs, things such as that. That way you can twist them on top of your HT and use them when you're testing it. Or you can use it on a QRP rig. If you're building a larger dummy load, it's going to take a little while longer to get that done. So, and then of course the low and bandpass filters. Those kits, I was looking the other day, generally for each band, it's about $6 on each side of that for each one of those. It's probably an hour and a half build to do that. So what are we looking for to have a successful build? We want good reviews from other hams. That's the first thing. If you went on right now on eHam or any of the other review sites and you typed in Pixie, it's a kit, CW kit, you're going to get probably some pretty bad reviews on that. A lot of them are Chinese-made kits. They don't have very good directions. There's no videos or photos online. The boards are diversely different. You might order one week and get this board, and order one the next week and get a different one with different parts. So you want the consistency, so get hams to review that for you. Buy the kit from licensed ham radio operators. So these guys are in it, they're vested, and they've made these kits themselves, they've researched it, and they're always trying to make it better. They're always trying to upgrade it and make it better. detailed plans with the kit and online and printable. So when I say detailed plans, this was, I think, I don't know, 2008, 2009 when I got this. This is how many pages, almost through it here. That's how many pages he sent with this little QRP radio. Very detailed. So I didn't have many problems, but when I did, he didn't have very much stuff on the internet, but when I did, I could just call him. And he would walk me through the process because he was a licensed ham and he had a vested interest in this. So I usually print out the keyer that I have over here. I printed out the manual for it when I was doing the build. I like the nice big pages that I can just flip over and read. I'm pretty bad about that. Some people that are a little more modern, they just put it on their iPad and go. So I like having support from things such as like Yahoo groups, blogs, websites, things such as that, because you can send messages to people. Believe me, if you're having a problem, they've had this problem. And you'll have an answer just really quick, and they'll help you through it. So, and I've already talked about the build videos, pictures on the internet. It's just really handy to have that. So I made a decision for you guys that we're going to build this QRP Labs QCX Mini. It's a 5-watt CW 20-meter transceiver. So I ordered it after I found out I was going to be doing this presentation. And so it came from Istanbul, Turkey. And there's a ham over there. He's been doing these kits for a while. So I'm just going to kind of pass this stuff around and let you guys see what comes in a kit. And it's going to look a little bit overwhelming at first, but it's really not that overwhelming. And James is going to cover kind of the other side of this, but I can't tell you how important it is to go ahead and read the directions, make sure you have all the parts, check off on the list, identify those parts, and everything else will go together simply. So this is the, well, somehow this goes together. This is how big this 5-watt radio is right here. I mean, a little bit bigger than a pack of cigarettes. If you just hold it together like that, you can pass it around. I guess I'm just going to throw that in there. But you guys feel free to get the parts out and take a, please don't open the bags. So it is. And I bought that extra. I bought the case, I think, for $18. So, you know, yeah, take those bags, flip them over. And so I would definitely recommend, I ended up buying one of these because the shipping was paid for. I bought that, the ship. So I bought a, I believe this is a 20-watt dummy load max. And so it sandwiches between two boards. So you do one side of the board and then you flip it over and you do all the contacts on the other side. James, you have 10-watt, right? So James does a lot of QRP stuff, and I'll just pass that around too. So the next slide is going to say something about how much fun you're going to have building this. And I'm not going to take up too much of your time, or much more of the time anyway, but I want to let you know that if you want to try something like this, you can call me anytime. They have my phone number listed. I'm not that great. I'm not technical about it, but I do have a hammer and an anvil, and I will help you build a radio if you need help building a radio. So I was talking with Ron, and the reason why my presentation might be just a little bit short tonight is James is going to spend some time, but Ron and I were trying to speak, and his wife was in the car with us, and she wouldn't let us get a word in edgeways. How long did it take, Ron, for us to finish that? An hour and a half to finish that conversation? So, and I was typing the whole time. Oh, there it is. So that says the fear of ... So don't be afraid to build a kit. It's a lot of fun. Even if you mess up a part or two, it's okay. We can get more parts and we can fix it and we can keep right on going. You will have a blast with this, I promise you. So I'm going to let James come up now and hit his part, or it'll be midnight before we get out of here. Thank you, guys.
All right, well, thanks, Greg. We've been kind of communicating back and forth sort of how to do this, and So what I'm going to talk about is kind of where do these kits come from, and what does it take to kind of make these things so you can go online and click a couple times on a website and get a kit delivered to your house. There's a lot of work that goes behind that, and we do have a little company, but I'm not really talking about the commercial side of things, but I will introduce, this is my wife Kathy Long back here. If you order a kit from us, it's highly likely she kitted it, and if it's correct, it's very likely she kitted it, because I don't get to kit very often because I'm known for getting distracted and making mistakes. So it's a process you have to do very carefully, because you're putting sometimes hundreds of parts into a kit, getting them correct, getting the right parts, getting them in the right, we organize them by type of part and so forth, so it's easy for people to sort them when they get it on the other end. So a lot of work goes into that. But anyway, before I dive into that, I'll tell you a little bit about how I got into kit building. I, kind of like Greg, I was somebody who tinkered with things and scrounged, and have done that. Actually, I still do it now, but even I think our first flat panel TV we got from our neighbors who were throwing it out because it wasn't working, and I drug it home, tore it apart, and actually managed to fix it. And so I kind of, I like doing that kind of thing and tinkering. So in high school, I got interested in ham radio, and I needed to learn Morse code at that time to get my license. And so I needed a code practice oscillator, so I actually picked one up from, some of you may remember, I think it was Bernstein Appleby in Springfield, the little electronics shop that was up there in Springfield, Missouri. And so they had a little code practice oscillator board kit, came as parts in a kit. First kit had never built a kit. I didn't have a soldering iron. Realized, got home, I'm like, oh, it's a kit. How do I build this? Well, I didn't have a soldering iron. What I had was a wood burning tool. Not optimal by any means, right? But it sort of looked like a soldering iron. I thought this might work. I found some solder in a kit I think my mom had for a stained glass panel or lamp or something. Now, some of you know what's wrong with that, right? Solder was acid core. So I built the kit. It worked for a little while, and then as soon as it got humid, it kind of got very intermittent and never really worked right. Fortunately, long enough for kind of get through the CW phase to learn Morse code. But I learned a lesson from that. But I built it. It initially worked, even with that kind of non-optimal situation. I got that kit working. So that kind of got me hooked. And it's one of those things. It's when you have fun, you have a positive experience, and I still get excited when you take a handful of parts and you put it together and you turn it on and you hear a radio signal. That to me is still the most amazing thing. There's this little collection of parts, and I forgot to bring one I'm tinkering with right now, but it's a really cool little design. If you know what an LM386 is, it's a single IC basically op amp, but it's audio amplifier. Someone figured out that you can put that thing into oscillation mode and make a regen receiver out of it. So I've been tinkering with that. So it's literally a single IC and a few resistors and capacitors, and you've got a receiver. And it provides amplification, so it makes a very simple radio. So there's little things like that that are just amazingly fun to play with. So, but anyway, let me get into this and talk a little bit about the kits here. Let me see if I have the right button here. I think I do. Is that the one? Let's see. Yeah, there we go. I think that's it. Nope, wrong one. Okay. We have multiples here, and that's not working either. Okay. Okay. All right, we'll just do it the old-fashioned way. I think the mouse click should do it. So, as Greg talked about, there's a lot of places we can do kits. Is it possible to turn the lights off up here for the front row, Tom or Don? Thanks, perfect, yeah. Some of these will be a little hard to see otherwise. So, at the bottom is one of the kits we do, and at the top is a kit you can find on eBay. And they're kind of comparable in what they do. They're both single band CW transceivers. Greg mentioned the Pixie. That's the Pixie that he was talking about. And that's pretty much what you get when you order one of those. You get a bag of parts and you get a circuit board, and you really don't get a whole lot of stuff. You notice that includes shipping for $14.99. It'll ship free from China. For us to ship a package from here to China costs us what, $16, $17 minimum? So we could not even ship a kit back to China for the costs that they're delivering for. So there's obviously a lot of subsidies going on there and things that make that even practical. So the comparable kit we have is priced at $40, but that comes with all the work that goes into developing it, supporting it, helping the customers understand and help them through the build process. So let's. Ah, okay, that's it. Yeah, there's 3 of them up here. That's the one I'm looking for. Thanks. There's literally 3 of these. Great, thank you. Thanks very much. So, you know, as I said, kind of how does that kit get to your doorstep when you go online and order it? You know, where do kits come from? You know, this is one of my favorite. I think this is Far Side, but you know, it's kind of like you have an idea and some stuff happens and a miracle occurs and suddenly you have a kit. And it's not quite that way. It's not quite that easy, unfortunately, but it is a process. So here's kind of the development steps that you go through in kind of creating a kit from scratch. You start with the idea, you know, look at the market interest and say, hey, does somebody want this thing? Is there something people will use? And develop a concept for it, you know, tweak it, refine it, talk to people, go, hey, what do you think of this idea? You build prototypes. You test them, you debug, and you keep doing that process over and over until you get to a kit. An interesting point here, let's see, is this a laser pointer? Okay, doesn't work well on that screen, but anyway. The kit in the middle, we designed this in a parking lot following a ham radio meeting. So a friend of mine and I, who's one of our designers, he's an EE by background, by training, we were at a radio club meeting and we asked people, you know, what kind of kits would you like to see? What's something that doesn't exist? And a guy back in the back said, well, I do a lot of work with tuned magnetic loops, and I'd really like something that would indicate the RF power of that loop visually. So I can set it near it, go over here and tune remotely and see when the loop's creating the maximum RF field. So that little kit in the top center is a field strength indicator using an LED, using the brightness of an LED. We literally designed that in the parking lot, sitting in the parking lot talk through the design. Kit, who's the designer, by the way, his name is Kit. He's a kit designer, but his name is Kit. And WA6PWW is his call. He sent me the next morning a schematic. And we converted that to a board and we prototyped that. And that's we sell a lot of those. It's a very popular selling kit, and it's a little simple kit. It's easy to build, and it works great for testing your HTs, transmit, looking at RF levels. It'll pick up pretty much anything from DC to about, you know, 500 or 600 megahertz. ARL actually tested this, and the guy said he actually could see his microwave leakage on his microwave that had a bad door seal. So you know, the transistors are kind of losing, but it does work a little bit even up there. So, and then some other things, the picture, just some of the stuff we use, some of the test equipment and so forth to actually go through that process. And then, you know, how do you convert it to a commercial kit? So you got to go through and source the parts. You know, once you have a final design, you go and build and test, because when you change something on the board or you change something in the circuit, I can almost guarantee it's going to cause a problem. You know, you think, oh, it's a slight tweak. Well, sometimes that causes a problem with how it operates. And we have to do the documentation, and that's a whole process in and of itself. We work with other people who help edit, sometimes help write some of it. We write some of it ourselves depending on the kit. And we develop the manual, all the pieces that go into it. We've people who do test building, so if there are people here who like to build kits, talk to me after the meeting or get in touch. We are always looking for people who want to build stuff, and you'll get stuff before it's commercially available. You get things that may never become commercially available, but you know, you'll get a chance to build some fun stuff. And at the end, we sell the kits if we're successful with that process. You know, for testing, you look at a lot of different things. The upper left is modeling software to model, and that's a low-pass filter. That's what's called a Cower or elliptical filter. It has, let's see, 2 resonant inductors that are resonated with capacitors, so they're resonant traps, and then it has the standard roll-off you see there. And the upper left is the modeling software for that, given the component values. We're seeing on the bottom is an actual measurement. You obviously see the real measurement has some noise and things on it. But most of that noise is because we're looking down here, we're at about -70, -80 dB down. So that's just noise because the signal is so small. But that actually hit pretty much right on target with what we were targeting and modeling. So it's always nice when that happens. It doesn't always happen. Then the documentation. As Greg mentioned, one of the key things is having something you can follow, instructions, take you through that process of building. We often go through, I mean, tens of iterations of getting it right, tweaking it, we'll get something out there, we'll find an error in it, or we'll find a change, or a customer will say, hey, I'm stuck here, I don't understand this, and we'll go back and revise it. We do that all the time. Our little receiver, for example, we're on version 7 of the documentation. I think that was a while back. I think we've actually revved it a time or two since then. And then part of the other key aspect of doing this and making it successful, we want people to be successful in building kits. And so we provide customer support. When you buy a kit from us or from any good vendor, they'll stand behind that kit. They'll provide parts that fail. They'll replace parts that you lost. I mean, we had a customer recently, I'll share this story, contacted me and he bought, I believe it was a Tribander, right, Kathy?
Our Canadian order?
Yeah, Canadian order. So he emailed us and he said, I'm missing a whole bunch of parts from my kit. Now, Kathy is very good at kitting. I'm not. I'm like I said, I get distracted. If I do the kitting, she has to double check it, so it's better for her to just do it. But this guy got his kit and he's missing a whole, literally a whole, we bag parts separately. So things like diodes are in one bag, transistors are in one bag, resistors, capacitors, et cetera, are separated. He was missing something. And we said, okay, we said, we're pretty sure everything was in there. We have a checklist process to check it. We think it's there. Well, he didn't find it. He said, no, it's not there. So we're getting ready to send him replacement parts. I get an email from him. He said, I found the parts. Apparently, he had laid all the parts out on his bench to sort of inventory everything, all the little bags. He has a cat. The cat decided to play with it. They found the bag of parts under their refrigerator only because they decided it was time to clean the fins vacuum out the fins under the refrigerator. They would have never found it otherwise. So it was one of those things where like, thanks for finding that, but it was, you know, those kind of things happen. This is another example of a customer. So I got this email from a customer. The name will remain confidential to protect their, you know, what's the old saying on Adam 12? The names will remain, names are changed to protect the innocent, that's it. I'm not going to change it, I'll just keep the names out of it. But I got this message from him. And there's some clues there, but the one I always love is, we always get these that, you know, I've checked the soldering. So I said, send me a picture. So he sent me these 2 pictures. And so I went and took the picture and zoomed in as far as I could, and I looked a little closely. And you'll have to look closely. I'm not sure if you can see it, but...
You might have to point the laser at it.
Yeah, I will point the laser at that one. So if you look very closely, one of the keys is, he noticed his battery was off. This uses 2 9-volt batteries for a split supply, so the voltage should be 18 volts, or plus and minus 9 on the 2 op amps. And that was a clue. And so the first thing I keyed in on was looking over here at these terminals for the battery. These are the terminals for the battery holders. If you look closely at this one, and so what I sent back to him was I said this. You know, it looks like you have a bad solder joint in some of the battery terminals, and I sent him a picture of zoomed in on that. Now if you see it close in there, you can see on this one, there actually was no solder. It looks like it because the tab actually bends over, but there was actually 0 solder on that tab. And of course, he had gone back and checked it, but he just missed it. He's looking at, you know, as many of us will do, you'll look at something and not actually see what's going on there. And so he missed that one. And so I got that, here's the response. And, you know, solved the problem. So another customer, it's happy. But it's one of those things that, you know, we see over and over. So you'll see a lot of equipment here on soldering, and I'm going to talk a little more about that a little bit further in the thing. So given that lead-in, what do you think causes the most problems with kits? What do we see is the #1 hands-down cause for soldering? Exactly. It's not that hard, but it takes practice. It's something you need to learn, and it's fun to learn. It's something that's kind of like, you know, I do welding, I do all kinds of stuff like that. It takes practice, and you get, if you haven't done it in a while, you need to practice again. I've got a customer right now that's building one of our kits, one of our Tribanders, and he's having a problem that indicates there's some bad solder joints in the signal paths, and basically with his front display not working. And I sent him a reply, kind of like I did to this previous one, and said, please check these solder joints. The response I got back was, I'm a master solderer, my solder joints are all 100% perfect. And I said, okay, well, I'm not sure I can help you. You know, I ask you to resolder these connections because he was having intermittent of the front display, and that's almost guaranteed to be either on the microcontroller pin solder, the inline resistor or the front panel connector to the main board. And we've seen that over and over, but I can't get him to just go and resolder those connections. He's so certain they're perfect. So it's always a challenge. I think Greg talked about a lot of this. Stuff doesn't have to be expensive to do soldering. There's a lot of stuff out there. I'm actually missing one of my, oh, there it is. Okay, I had it. That's a soldering iron on Walmart right now for $12.99. I've got one over here. I think this was somewhere at like Harbor Freight or something, was $1.99 on sale. And it'll work. I've built stuff. I built kit with a wood bending tool. So, you know, you can build, you can build kits with anything, any reasonable soldering iron. These kind of step up in different levels here. I'll do this over here so you can see it. You know, this is $12.99. This is a station you can get on eBay for about $40, or this is actually Walmart.com, but whatever. You know, they're all kind of merging together, but that's a $40 one. This is a Weller station. These are sort of, you know, the Cadillac of soldering stations, $120. And one of the things I liked here was then these two bottom things are home built. People have literally built a soldering iron here, a couple of AA batteries, some resistance wire, and a little piece of heavy copper, and build a soldering iron, right? The other one's running off 12 volts, same thing. You go online, there's a ton of how to build your own soldering iron, you know, so you can literally build one. And then I really like this dispenser. It's built out of Legos, right? So I thought that was just really cool. And, you know, just little stuff like that. Have fun with it, you know. I mean, you don't have to spend a ton of money to do this. As Greg said, you can get a multimeter online for 20 or 30 bucks on eBay. You can actually get a lot of other stuff. I've got an RCL, which is resistance, capacitance, inductance meter. I think it was $35 on eBay. You can get a lot of tools that really, really work well. So, you know, just if you're learning to solder, one thing, you know, some tips. Use good quality solder. You can buy some cheap solder on eBay now that comes out of China. I've tried some of it. It melts in consistently. That whatever the flux is really poor quality, and it just won't always wet the board or form a good joint. You really want to buy something decent. It is getting expensive. This is Kester, I think, solder, rosin core, 6040. A pound spool of this is now about 30 or 40 bucks. It used to be like 5, you know, or 10, but everything's getting more, welcome to, you know, everything getting more expensive. But also keeping the soldering iron tip clean, right? So good solder. This is a, you know, a little tip cleaner. I've got one of them over here. They're a little container like this. Actually, I should pass some of these things around. That's a good point. You know, but this is a little, it's got a little stuff in it. You dip the tip in, it kind of chemically cleans it and tins it so it stays nice and shiny. It really does look like you see here. It'll go from black to shiny. When the tip is black, you have poor heat transfer into the part, so it's a lot harder to get solder to work. Tip's clean, it'll work really well. And I've got some videos I'll show you just in a minute of how easy that is. And then always remember this. So Greg mentioned places to do your work. This is my bench in my garage. This has taken some work. We were before we moved back to Arkansas. I'm from this area, but I spent 7 years out in New Jersey, and then we spent 21 years in Silicon Valley. In Silicon Valley, we had a little 1,000 square foot ranch house. I didn't have this kind of space, so the kitchen table was a place to build. You know, a desk in a bedroom. Wherever you can find space. It's not that hard. You don't need a ton of space. One of the things you can do, a little trick here, a few of the things I'll point out, and you'll see a lot of equipment here, because we do a lot of test building now. That's most of the building I do is testing things we're working on products. But a couple things that are really handy. You see a stainless tray in the middle. You can get these things at, you know, I think we got these at a dollar store or something. They're not very expensive, but they're a great way if you're working on a kit and you drop something. It doesn't roll off the table, it drops into there. We had one customer, it's one of our favorite emails, I forgot about this. We have a surface mount kit that's a digital dial. It's a frequency counter and it's programmable for offset. So you can put it in almost any radio and it'll give you a digital readout of the frequency of the radio. We had a guy who contacted and said, I need some more parts for my kit. And further down the email it said, I was working on it, I put all the parts out and I sneezed. And I have carpet. And he said, I can't find them all, right? And we laughed over that for quite a while because, you know, and then we sent him a complete new set of parts because I just said, no problem. We had so much fun with that. That was kind of nice to hear because I've done stuff like that. And yeah.
You need to tell them, the more you make us laugh, the more free stuff you
Yeah, that's a good point. Yeah, because, you know, we calculated last year, I think we made, what, about 50 cents an hour each doing this, something like that. So we're not getting rich in this. We're doing this for fun. And this is not my day job. This is what I do for fun, and we do for kind of enjoyment. And so when customers have a good time, when they appreciate stuff, we get some really nice notes back from people, and that's really appreciated because it kind of makes it worthwhile and makes it, you know, keeps it fun. But yeah, just, you know, some place to work that's comfortable, well lighted. You'll see there's a lot of light there. I've got how many lights on that bench? I think there's, let's see, oops, sorry. There are 2 down here. There are the 2 arm lights, and I think then there's overhead, there's 2 fluorescent tubes that are 5,000 lumens each right above the bench. So I like a lot of light when I'm working. And I've got a little microscope there for looking at parts and stuff. That comes in handy. And then down at the end's an oscilloscope, 6.5 digit multimeter, frequency counter, and stuff like that. And then above is some power meter and tests, so I use for testing transmitters and so forth. And so dummy loads behind it. You know, then I've got a sound system, subwoofer, so I can music when I want to, you know, hang out there and listen. And just kind of a nice, you know, any place you can go and work. I mean, again, you can build something in a corner, you know, take over a garage, take over your table, whatever works best. Greg talked about this, then when you're building, you'll occasionally make mistakes. I try to make, you know, limited mistakes, but I've made 1 or 2 in my lifetime, and, you know, it's good to know how to fix them. And Greg talked about the solder suckers. There's also solder wick. We got some, I think I put some over there for the door prize pool, so some of you may actually win some of this. So if you win, you're going to have to actually use it, find a way to use it. It's a lot of fun. It actually works really well if you get the soldering iron, use the wick and basically flow the solder, reflow the solder. It's coated usually with rosin, so it sucks up the soldering stuff, sucks up the solder into the wick and then cleans the connection. And if you do it right, you can often remove all the solder out of a board connection and the part will just fall out. So it actually works really well. It takes a little kind of figuring out the right temperature and time and so forth, but the stuff will work. If you buy quality stuff, don't buy again, it's the stuff you get on eBay, won't work nearly as well as the really good stuff. So some of the changes that you're seeing happen, and I know Greg's got a few surface mount kits here, and I'd encourage all of you to come by and look at stuff here when you on your way out or as you pass by, but give you an idea. Surface mount parts, most of our kits are surface mount. We are moving to things that are going to be more and more, or through-hole parts. We're moving to more and more surface mount part as we start prototyping things. The reason is through-hole parts are getting harder and harder to find. And with the supply chain issues we're having right now, some of the through-hole parts have gone away, and the vendors are quoting us delivery times of sometime next year. I think one part we use is the next time we could buy it. Fortunately, we have a lot of them. We don't need them. But the next time we'd be able to buy it is July of 2023. And that's a common part. It's a MOSFET, 3-pin TO92 transistor type device, MOSFET. Just not available, just out of stock everywhere. Some of the little microcontrollers. We use a lot of microcontrollers in some of our high-end radios. Those are gone. I mean, everybody's out of stock on the same thing. They're quoting sometime in May of next year for the next round, next time they expect to have more. So it's getting tough. So surface mount parts are kind of where things are headed. And one of the things is working with surface mount parts. It's actually, in a lot of ways, I build a lot of surface mount stuff. I find surface mount stuff in some ways is easier to build than through hole. And one of the reasons is, I'll show you this in a video in a moment, the parts don't fall out of the board as easily. If you sneeze, it's a problem, but if you don't sneeze, you're in pretty good shape. This is kind of, though, the challenge with surface mount stuff. Your cell phone now, if you see the top, the Imperial Code side, the 1005, that's currently, I believe, the smallest production. But that thing is literally like a grain of sand. You really can't hand solder those. Most of our kits, we do 1210. I've got some examples over here. We do 1210, 1206, and 0805. That's as small as we go on parts because those are reasonable size. You can actually work with those pretty easily. And I'll show you some videos here in a minute of some soldering with those parts. But this is, if you look in your cell phone probably has the 1005 size parts, and so those things are, if you open it up, you'll hardly notice there's a part on the board. You'll see sort of the little pads, but you won't really see the part on the board. It's hard to see with your eyes. And then there are a lot of these packages for transistors and things. We work down to the SOT 23-5 we have on a couple of kits, and most customers are able to solder those pretty well. The ICs get a little tough when you get below the 0.5 millimeter spacing on the pads, because that's hard to do by eye. You start getting to the point where you have to work under a microscope, and that can be a little challenging. But fortunately, the larger parts are still available, and so we're able to do some things like we have a dummy load kit that I'll show you in a minute that's built on around surface mount, and it's 1210 size parts. They're actually really big, and so let me cue up some videos here, and I'll just show you some quick soldering techniques. I think we'll be able to get this to work. We had a problem with the USB stick earlier, but let's see if this will actually do its thing this time. Okay. So this is just showing a through-hole build, and this is me putting the capacitors in. Yeah, let me see if I can, there it is. Yeah, we might have made some comments that you don't want, especially when you see what happens next, right? So I stuck these parts in, and I tried to reach under the board and kind of bend the leads, because you want to kind of flare the leads out so they're holding the board. Right. Yeah. And of course, then I flip the board over, and what happens? There goes the, there goes the part.
It's the Band-Aid.
Yeah, the Band-Aid's real. It's healed now. It's a little bit, but yeah. So so I learned my lesson there. So I go back and redo that. But we'll let me shift to the next one here.
It's a really nice board holder.
Yeah, that's another thing that's on eBay. Yeah. Let me, how do I get to the next one? Here we go.
They had those at Radio Shack in Fayetteville.
Oh yeah, that's a good point. They probably do. So anyway, this is doing it right this time. I bend the leads on the little one first, and then roll it over. So I'll skip through that. This is now soldering, or actually, well, I want to go back to that one. That's why I kept that one. Let's skip through that. Apologies here. Skip partway through this. Okay, there we go. So now what I've done is I've flared the leads out so they kind of hold in place, and you can also push them up. But then this is how you solder, right? This is kind of, there's a lot of videos online showing you how to do this, but I want to watch closely, because there's a key point here. When you bring it in, bring the tip in first and kind of heat the part, and then bring the solder in. You want to get the pad on the board, you want to contact the pad on the board and the part lead, and then feed the little bit of solder in. And then notice I keep it there like a couple of seconds afterward. And that's to keep the solder flowing and let it flow into the board. So you just leave it there for just a moment longer. This is just, from practice doing this. I actually tried to generate a bad solder joint for this, and I couldn't make one for some reason. I wasn't able to actually do it. I needed to try harder. But so that's really how easy it is. I'm going back now. You see I'm going back and actually remelting those just one more time. And it's just kind of a, just absolutely to be sure they're well melted. And so that's really it. And let's see. Okay, and then the last step, as Greg mentioned, is you go in with like side cutters or in nippers and just take off those leads, so they don't short out.
So once you do that, if you turn your board over and you wiggle your parts and they're holding, you should be good, right?
Well, yes and no. I mean, you can have a solder joint that mechanically will hold the part in, but it cannot be electrically. And what will happen is if you don't get it hot enough, some of the rosin will stay right around the part, around the wire, and it acts as an insulator. So you may have a mechanical grip on it, but you may not have the solder may not have electrically bonded to the wire. So that's what's called a cold solder joint. And that will be mechanically okay, but it will probably electrically, it may work initially, but it probably will degrade over time. So that's kind of that process. And then, oops, let's see here. What happened? Okay, it's going to take it in the other order. Okay, let me go back to the beginning here. Okay, so now here's a couple of videos on surface mount parts. This is an 0805 size part. That's a capacitor. Gives you an idea of the sound. I'm just setting it on here to kind of show you the pads and how it goes on the board. And this is a pair of tweezers. You know, these are, you just use a pair of curved tweezers. It's real easy to handle the parts with. And, you know, that's the solder to give you a size comparison of the solder to the part. And then there's multiple ways to solder these down. I'll show you a couple of those to kind of show you how the process works. So this is my preferred method if I'm doing it by hand, which is, let's see, next video. So what you do is just basically put some solder, a little bit of solder on one of the pads. And you'll see here in just a second, I'll come in with a soldering iron tip and the solder. And there it is. And I'm just going to basically put a little dot of solder on the pad. And I'm not really trying to flow it a lot on this pad or anything at this point, just so I can get it kind of there in place. What happened? I guess I had a, whoops, next one. We had a glitch there. I think my soldering iron wasn't turned on, so. This should be the, that was the failure to, you know, failure to be prepared. This should be the actual, yeah, here we go. So now the soldering iron is warm enough to actually melt. So I'm just melting a little solder onto that pad and really just leaving it there. I'm not trying to heat it too much. I want to leave some of the rosin in. And now you come in with your tweezers and bring the part in and just reflow that with your, and kind of stick it in. Of course, your hands shake a little like mine. You have to kind of get it in place and kind of get stable, and then just let it, you know, let the solder condense. And now you just, you know, you can do this, you can reposition it. If you don't like the position here, it's not seated down the board, you can kind of scoot it around a little and reflow it. And then once you get it where you like it in position, come in with the soldering iron and some more solder. Now you want to make sure you contact the pad. Now watch close, you'll notice I bring it down on the pad and then against the part. And then I flow the solder in the junction, because one of the things with surface mount, it's really hard to do is get the board hot. Because for through hole, you're heating the wire, and the wire usually passes through the board and it'll conduct heat. On surface mount, the part's sitting on top of the board, so there's not a lot of contact between the part and the board. And so you really want to contact that pad with your soldering iron if you're using this technique, and make sure you get the board hot, that pad hot, as well as the part. Otherwise, you can get it, again, mechanically stuck to the board, but you'll have something like solder flux or oxidation that's in between the pad and the part, and it won't actually have a good contact. So let's see. I think this is just another example of the same thing. I'll just show you another one. There's one already in place, and I'm going to go in and put a little solder on one of the pads, like that, right? And just bring the part in. So again, it's actually not that bad, you know.
Did the surface mount components already have solder on them?
They're tinned. They have kind of a tinned ends on them. Yeah, they have electrodes on the end of the they're a piece of ceramic, and they have ends on there. They're plated on the end. Yes.
They handle the heat pretty well.
Yeah.
You're doing that, so
I mean,
you can kind of lay into it.
Oh yeah, you can. I've actually heated stuff and melted the pad on the other side through the part, and they still work just fine. They're designed to go through reflow systems and things where the parts can, as long as they're not at, I think the spec for most of them would be, you know, 500 degrees Fahrenheit for 10 seconds or 15 seconds, something like that. I mean, they're pretty tough. So the other way to put surface mount stuff down, let's see here, I think this is it. So there's another way to do this, which is using solder paste and a hot air gun. And you'll see one of those over here. I've got an example of the hot air gun. So what I'm doing here is I'm actually heating the pads a little bit. That's the tip of the hot air gun coming in. And I'm just heating the board a little. It helps the solder paste flux stick a little bit. And the paste flux comes in a syringe, like a, you know, probably about a 10 mil syringe size package with a little blunt needle. And so you'll see me now, if the board's warmed up, I come in, it just helps it flow a little on, or stick to the, you know, stick to the board. And so that's the syringe tip. I'm just going to extrude a little bit of this out and leave a little dot of it. You don't need much. It's really a tiny amount. You don't need a lot of it. So you notice I'm just kind of leaving just a little bit on each one of those pads. So you see there's very little. There's just a tiny bit of solder flux there. And once you have that, you can then bring the part in. I'm going to do one more here. And this stuff is just a solder-bearing paste with some solvents and things in it that kind of will evaporate or go away once it sees heat. The liquid acts as a flux to flux the connection, and then that will kind of, you know, evaporate and and go away. So next step, now you've got that, is place the parts. So these are a couple of 0805 surface mount resistors. Nice thing about the resistors, they have the value label on them. Capacitors don't. Somebody down the line decided that capacitors would not be labeled, I guess, years ago. The ones that are harder to test are not labeled, right? So I'm not sure who decided that made sense. But this, now you just sort of push these down into that, into that flux, or into that paste, and it acts like a glue. It'll stick them in place and kind of hold them. You could turn the board upside down. They won't fall off at this point. And then you just bring the hot air gun in, and you'll see me bring it in a minute. And we're going to heat up the connection, heat up the board with hot air. The hot air gun's running at, like, I don't know, what in Fahrenheit would be around 600 degrees, about 3 to 350 for the air. And so you'll see that solder paste start to flow. And the board, sometimes the parts will move around a little bit. Now if you do this, a lot of times the viscosity, the surface tension will actually pull the part perfectly oriented. Sometimes it works, sometimes it doesn't. This is the case where one kind of worked and one didn't. But you'll see in a minute how you deal with that. So while you have the hot air gun, just come in with the tweezers, nudge it a little bit. You'll see it kind of, when the surface tension, see it pull it in, right? Once it gets oriented, it'll kind of pull it into position. And then you just let it cool, and that's it. And then just, you repeat that process over and over, and that's it. So I'll stop there. So that's kind of the process for doing, both through-hole and solder. And I would encourage you, if you haven't built something in a while and you're interested, or you've never built something, check out things. There's a lot of things available online, a lot of options. Yes?
You brought up about cleaning. Some things don't need to be cleaned. Is there certain solders that you definitely have to clean afterwards, and what would you use to clean?
Depends on the solder. So there's two main types of fluxes. The rosin-based fluxes, those tend to dissolve well in alcohols. So the best solvent for rosin-based flux is ethanol, actually. So isopropanol will work okay. Most of the modern fluxes, the new ones, are where they call water-soluble fluxes, so just wash them in distilled water. I've got an old toothbrush that I just, if it's water-soluble, I toothbrush and I go to the sink in the garage. There's a sink not too far down from the bench, and I just literally scrub it down and wash it in water. The surface mount fluxes are all water-soluble. I still like rosin flux. I like the rosin. I like the smell of the rosin when you're working with it. It smells like pine. When I was in Silicon Valley, I joined this little startup company, and it reminded me of that story. But one of my colleagues was, he's actually Chechnyan, but from the Soviet Union, and he had come over, he's a physicist, and we needed some solder paste. We were trying to do some soldering and build some circuits, and he went out back and scraped the pine rosin off a tree, brought it into an oven, cooked it down a little bit, and we used that. And that was some of the best solder flux I've ever used, right? I need to do that again and make a batch of that, because we used it for years in that company. It was passed around to all the electronics techs and engineers that were there that we brought in, and they all used it for building stuff. So I still prefer the rosin flux, and so alcohol or a solvent that won't damage the board is good. I mean, acetone might discolor the board, so I wouldn't use that, but methanol, ethanol, isopropanol. Yes?
One thing you might mention on the subject of solder, for anybody that's going to get into this, is to get leaded solder and not, you don't want to get the green stuff.
Yeah, it's a personal preference. I have used lead-free solder in things where I need to, but the leaded solder is a lot easier to work with. Just be careful with it, don't eat it. If you don't ingest it, wash your hands, wear gloves. You're not going to breathe a lot of lead vapor because you're not getting it that hot, but use some air. You'll notice if you go back to my, let me go back to, let's kill this here. So on the bench here, that was something I didn't mention. If you look down here at the left, just past the lamp, that's a solder fume extractor. Those are not very expensive. It's basically a fan with a carbon filter in front of its activated charcoal filter, and it just sucks the air through, and it takes a lot of the solder smoke and stuff out. I find that if I do a lot of soldering, I have respiratory irritation for a day or two now. I used to do it and didn't bother me, but so I started doing that. There's also I usually have a fan setting up on the shelf up there that's blowing down across the board. So I have this kind of airflow just to carry the smoke and stuff away. But but again, lead solder is It's a preference. I don't own much lead-free solder. I think there's a tube of it over there, but I've used it on a couple things, but it didn't work nearly as well. It's not as easy to work with. So let me pass a couple things around here. I'll just show you. These are...
Were you not using any magnification when you did
the build?
Yeah.
Oh, the surface mount?
Yeah.
I'm using this. This is another little tool here. Actually, let me just switch over here for a second. This is a little magnifier. Where's the camera? There it is. So let me see if I can slide this in. This is a little thing I found on eBay, and it's a little magnifier, right? This is kind of example. This is a 1/4 watt resistor. That's an 0805, 1206 and an 0805 surface mount part compared to standard sort of resistor and capacitor. I use a lot of magnification to answer you. Cheap way, yeah. Oh yeah, solder sucker, okay. That's going in my pocket, I like that. Real cheap way to get magnification, dollar store. They have them up to 4, these are 3.25, I think they go up to 4.5x. They work really well. They're now they're $1.25 if you go to the Dollar Tree. But they work great. I mean, that's a good way to be able to see what you're doing. And yeah, as we get older, we all can't see. I'll pass this around. This is Greg, so that's his solder sucker. I'll pass around just a few kits. We've got a few sort of beginner kits here. I would encourage you, as he said, if you're starting out, this is our little dummy, this is a dummy load kit. And other people make these, so you can get it from somebody, but it's a great thing to have because you can test transmitters. Ours and most designs have basically a little circuit here that gives you the RMS and peak RF voltage with just a multimeter. So with a DC multimeter and this, you can measure your RF power output and know what your transmitter is doing. So very simple little piece of test equipment. And again, you're doing a whole bunch of repeat solder connections. So let's pass that around, take a look at that. The neat thing is when you finish it, test it with your multimeter. It should be 50 ohms. If it's not, you've got a bad solder joint somewhere. So it's a great kit to learn soldering on, just to practice. This is a little kit we did a few years ago. It's been really popular. This was, I think, featured in QST as well in one of their reviews. It's called the Walworth Tamer. Takes basically any old Walworth power supply, laptop supply, whatever you've got sitting around in a box somewhere, connect it to this. You don't even have to worry about polarity. It's got a bridge rectifier on the input, so plus or minus doesn't matter. Just connect the 2 leads in. It's going to go through. It's going to get polarity corrected, rectified, filtered with capacitors and with an adjustable voltage regulator. So you can take an old 20 volt laptop supply and get a 0 to like 18 volt DC power supply out of it. So that's a neat little, and that's also a good little starter kit.
You're talking about reducing noise, hopefully significantly.
Yeah. Oh yeah.
Walworth.
Yeah.
How do you find faulty Walworths? What's the best way to identify them?
How to identify them? Probably with a scope. I mean, a DC multimeter and a scope. Check the voltage and then look at the output, because if usually they have limited filtering or regulation. If that starts to fail, you're going to see ripple or you're going to see noise or all kinds of things on the output. If they're switching, all bets are off. You can see 100 kilohertz stuff. You can see a lot of stuff. This is another little simple kit. This is a little SWR bridge. Uses an LED brightness indicator. So once the SWR is below about 1.5 to 1, the LED goes out. Anything above that, it'll get progressively brighter. And you switch it in and out. And one of the neat things about these resistive bridges is they also protect your transmitter. So if something's wrong with your antenna, when this is in line, you'll never see more than about a 3 to 1 SWR. So you won't kill your transmitter if you're. That's another neat one. Then this is one, if you're learning CW.
No.
This is our little code practice. Again, handful of parts, little code practice oscillator. For us, it's a $10 kit. Other people have them as well. But a great way to kind of learn building, and you get something if you're going to learn Morse code to practice with. And we've also got, for those who want to practice, I brought, over here is a bin of parts. There's some bags here. There's some boards that have various, as we go through this process, as I said, one of our transmitter, I think we're on the 9th rev of the board. We've gone through 8 revs that didn't work right. So we have a lot of old boards. So if anybody wants to practice soldering, come over here, grab a bag, grab a handful of parts, and grab a board or two. Take them home with you and practice. Just stuff you don't worry about trying to build it, because the board probably won't work. As is, these are ones that had problems, right? Something was wrong in the design or in the board process. But they're great for learning to solder. Just take that board and stuff parts in it and practice your solder connections and look at them. Check them with your multimeter. Make sure you can check from point to point and see if the resistance is right when you put a resistor in the board. So help yourself to some of those if you'd like. It's what it's there for. And as I said, come by and take a look at some of the things. Another little kit we do, I'll show this one real quick, and then we'll try to wrap up here so we're not here all night. This is a little attenuator kit. If you do fox hunting, this was a request from folks who do fox hunting for us to do this. We have online, if you go to Thingiverse, you can download a 3D printable mount for this to mount it on the boom of a PVC or the beams that people build with tape measures, with a piece of PVC and tape measures. This will mount on the boom. This gives you up to 40 dB of attenuation so that as you're fox hunting, you get closer to the fox, you can just press progressively one switch at a time and take your signal down in steps of 10 dB. So this is something we're starting to sell. A lot of these people are starting to find out about them, and should be really popular with the fox hunting community because there's nothing else out there like it in this size range, and definitely not designed to fit right on the boom. So we'll pass that one around. Y'all can take a look at that. And with that, that's any questions?
Have you ever gotten any returns where the boards end up with fractured traces?
You know, I don't think I've ever seen a trace fractured. I have seen traces burned.
The reason I bring that up is I was in the aerospace industry, quality and reliability, and we were investigating an instance of that. So we went to the supplier. It turns out the ladies on the line, they noticed that the board was pretty flexible, so they figured they need to bend it a little bit to get it ready for their process of mounting components and soldering. And in that process of bending the boards, cracks and surface traces. So I thought I'd bring that up so nobody gets tempted to do that.
You know, I would hope they would, and you're right. I mean, the boards, you might be able to flex these boards, but when you do, you're putting the copper under either tensile or compressive stress, right? And so when you do that, it's going to possibly pop apart unless it can flex enough. And this
not just the traces, but the through hole.
Yeah. I mean, everything in that's it's not a good idea to bend them, right? I mean, that's the reason a lot of stuff that's vibration sensitive, if you've got a board in something that's really a lot of vibration, they'll actually encapsulate it in an epoxy, right, once it's built.
Is that standard FR4?
Yes.
Okay.
Yeah. It's just standard basic FR4 boards, yeah. They're plated through holes. That's one of the things, you know, early kits, if you look at, I've got some boards from early kit versions. Early kit versions, you didn't have plated through holes. You had just, you know, copper on one side. You didn't have component labels. You were lucky if you had holes in the board. And all of the stuff we do, most people do now, are through hole boards. They're plated through. They're a lot easier to solder. It's one of the things to look for. I didn't show that closely, but when you solder with a through hole part, which means it's plated through the hole, there's actually tin plating all the way through the hole to the top pad. If you solder that correctly, the solder will usually show up at the top of the component. If you flip the board over and look at where the component's setting, you'll see a little bit of solder around the ring. And that tells you got enough heat that it flowed up to the part. So with that, any other questions or anything? Well,
No, thank you.
Well, thank you very much for the opportunity. Thank Greg for the being the warm-up band. No, just kidding. No. Greg, it was a fantastic presentation. I think we all learned a lot. And, you know, as I said, Greg pointed out, we're here in Fayetteville. We do this for fun. So if y'all want a kit or something, I can't guarantee you're in our delivery area like Tom. Tom and I are literally probably a mile apart. So he was within our delivery zone. But, you know, we'll happily get a kit to you or bring something to the meeting if you want something. We do it for fun, and we want to support this. And I encourage all of you to think about it. And you don't have to buy our stuff. Go buy something and build it and have fun. It's a lot of fun. It's addictive. The one warning one quick warning. You know, it's kind of like once you start building kits, buying kits, you'll buy more, you'll get more. I've got big bins full of kits now that I haven't built yet. And it's kind of like Greg said, saving money, not quite right, because it's kind of like buying a bass boat to save money on fish. You're not going to save money on radio because you're going to buy too many of them and play with them. But it's a lot of fun. If you enjoy it, you learn, and you get to do a lot of neat stuff. So anyway, again, thank you very much, folks. It's great to talk with you.
On behalf of the Bella Vista Radio Club, I'd like to present certificates to Gregg Harrison, KF5WAP, and James Bennett, KA5DVS.
Thank you very much.
Thanks.
Thank you.
Thanks for the presentation.
Nice. Okay. All right.